Everyone, welcome back.
Hey, yes, our session just ended, so I assume it was like a timer, like ending in 30 seconds, sort of ending.
Oh, it's great to see so many smiling faces. What were the highlights? Did anyone have anything new that they learnt? Did anyone meet somebody new in the groups today?
We're still trying to figure out how we can make use of different data available to combine them in this EASI format.
Yeah.
Because the example, the case study that was shown yesterday is like the same data set with at different time. So like a temporal analysis, language change. But if with different, data sets, like for example, water observation from satellite combined with soil moisture data, so it's gonna something like that to look at what will be the marketability of the result of our analysis. Will it gives value added information?
Yeah, that's a really interesting thought, isn't it?
I might just make a comment from a couple of the rooms that I sat in briefly, and what I think is really good is that you can see that the discussions and the conversations are progressing. We're starting to talk about more about the data sets. What data sets could we bring together to solve a problem, and what might those problems be? So I can see definite progression in those discussions, which I think is really promising. And what I encouraged folks in the couple of rooms that I sat in to do was, in the upcoming tech salon sessions, please join that and ask those questions about, I'm thinking about doing this, this, and this. How do I start to do that? So we can start to leverage the big minds of folks like Matt Padgett and Caitlin Adams about, okay, this is how you can take your first steps towards putting those data sets together and creating that thing that you're thinking about. So I just encourage people to do that in the upcoming tech salons.
It's handy that you said that, Brendan, because we have just clocked over into the tech drop-in session now. So Caitlin is right here, as are a number of other great-minded people like Eric Lehman from Sarah. Brendan, of course, you are very knowledgeable in earth system science and earth observation science. We also have Rachel in the room. So there's a number of us here who can help you to really start to think about what Pastor has raised when it comes to realizing some of the challenges that come with realizing what we want to work on and seeing what the actual road looks like, what that journey from where we are now to where we want to be could involve that we may not have thought of before. Would anyone want to start telling us a little bit about some of the new challenges they've realized upon the journey they're on?
Rush, given that we've sort of got the booking form, Josh actually has something he wanted to discuss during this session. So Josh, if you're happy talking about it with the sort of broader group, I think there's lots that people can learn from the different questions. So yeah, Eric and I are here to have a chat about what you're interested in understanding. So maybe you could take us through it.
No worries. Yeah, sorry, I didn't want to hijack it if there's other things that.
No, this is what this session is for. So yeah, thank you for sticking your hand up and booking out a time. So yeah, everybody's just here to sort of learn from each other. So yeah, definitely not interrupting or taking over anything. This is our time.
I think I've been chatting about it with a few people as we've gone through, but apologies, this is sort of repeating, but I was keen to, sorry, I talked about it with Brendan. I have maybe a workflow that I've tinkered with in Google Earth Engine, but I want to it's around SAR data. So I know that had a look through the catalog, and there were maybe certain years of SAR data that were available potentially in EASI, but I just wanted to know, in the context of this hackathon, if I'm presenting something at the end of the week and I'm saying, okay, I'd like to do this in EASI, but the data's not there at the moment, can I present some of the results that I maybe already have from an existing workflow?
Yep, Matt's sticking his thumbs up. Matt, do you want to talk a little bit about, yeah, so perhaps I'll say first, and particularly for anyone on the call who might not have heard me talk about this in our earlier tech drop-in, we're really excited to see any ideas that you have as part of the sort of end of the week. You can have developed them, you know, using data you accessed this week or outside, using EASI or not. And really the thing to kind of think about is that this week is all about understanding your ideas, validating them, and then presenting them with the option to investigate further support that Geoscience Australia, CSIRO, and Frontier SI could lend to you. So I think Josh is a really great example of saying, I have a workflow in Earth Engine, I want to explore how it can come across. So we would definitely welcome that presentation, you know, as a submission, and that way we can sort of evaluate what it might look like in future to further develop it. So Matt, do you want to talk a little bit more about any existing plans for SAR data and EASI, perhaps, and that might help Josh understand sort of the timescales and things?
Yeah, so thank you. We're very keen to get SAR into EASI, so particularly Sentinel-1, and Sentinel-1 backscatter will be as an ARD product, will be the first item to come into play. And like we do with a lot of the other data sets, it becomes, our workflow is designed around global footprints, essentially. So we're not going to process the whole globe, but anywhere is available to us. So Sentinel-1 backscatter is the first step, but our workflow that will build and generate the Sentinel-1 backscatter will have the capability to, it'll use the ESA snap toolbox in the middle. So any, well, I call them recipes. I don't know if that's the snap terminology for them, but a recipe is a set of processing functions through the snap toolbox. So arguably we can drop in any recipe and create other variants, and we have our radar scientists elsewhere in CSIRO actively working on using the polarization aspects of Sentinel-1 to derive other features and characteristics. And it's an active research area to combine Sentinel-1 radar imagery with optical infrared from Landsat and Sentinel-2. There will be a number of research papers out there we can build off, and like Josh said, he's got some preparations, some workflows already designed in Google Earth Engine. So it's what we can do the data. The next question after that will be how we use it, which is the cool fun bit.
Yeah, thanks, Matt. Then a related question that maybe is more relevant to the broader group is, so my problem is change point detection and going through and having a look at trying to separate our time series into like two or more groups. And I assume that will be running through maybe a few of the ideas that come out. But one thing I was sort of, I don't know if anyone's had an experience with this, but like sub-pixel changes and them showing up within, let's say, a pixel size, in something like SAR or in Sentinel-2 as well, it doesn't really matter. But I guess the sensor is giving you an average over a certain spatial area. Yeah, do you have any experience in terms of like if something smaller than spatial area is changing, but significantly, whether that will show up in a small way in the overall? It's very problem specific maybe as well.
It's a really good question. So thanks for asking it. I certainly don't know off the top of my head. I know that one of the scientists at GA, Robbie Bishop Taylor, has done some work on sort of pixel analysis, but what that's leveraging, by my understanding, is like slight misalignments between satellite passes, which is allowing you to kind of get, you know, extra information based on the differences between the different passes. So I'm curious from any of our other experts or people on the call, whether you've had experience with, you know, how much can change in an individual pixel that you can still, you know, pick up a meaningful change.
I haven't looked at it. I mean, it depends what else is changing in the pixel. This side, if the thing you're looking at happens to be the only thing that's changing in the pixel, then maybe you could pull something out. But there could be 4 or 5 things changing in that pixel, and it'd be very difficult to figure out what they all are when you only have one pixel to look at. But yeah, that would be my gut feeling.
Yeah, if I can just chip in here. I haven't been looking at that specific issue myself. You're correct, Joshua, that, you know, obviously you get the average over that pixel of whatever's on the ground. And I think in my work so far anyway, and in most people's line of work, we're assuming that this is kind of a pure representation of what's on the ground, right? So we kind of do away with the fact that it's a mixture of many components on the ground. There is definitely, I'm aware of research at CSIRO and probably elsewhere where people work on the problem of trying to untangle these different proportions, right, of different constituents, and you might be assuming a certain number of constituents or components within that pixel and try to, with a particular spectral signature, if you like, and you try to disentangle that disentangle the signal, the overall signal of the pixel on the basis of these assumed proportions, spectral signatures. So you can do a bit of research. The term that's used there is called unmixing. Unmixing multivariate proportions along these lines. Again, not familiar with the topic myself. I know of people who are doing research along these lines. In fact, people in my team work on that at the moment. Are working on that. So there's definitely, you know, it's again probably an active area of research to get to the bottom of that at the moment.
Thanks. I'll look that up, and yeah, I'll look that up through the week, and that's great help. So thank you. The other question I had, because I had a few lined up for looking, which is very less related to the technicals of sensing, but I was wondering if anyone had experience sort of presenting uncertainty in these things and propagating that through to something that's client side. Is that, yeah, I assume that's hard to do at the best of times, but has anyone had experience with that and how to present that spatially? Are there any good examples that I should be looking at around that as well?
That's a very good question too. Thanks, Joshua, for all the good questions. Yeah, uncertainty, I deal a lot with uncertainty in my work, or trying to convey the idea that uncertainty is just as important as data, underlying data, right? So there's 2 different aspects there from my perspective. The first one is how to compute uncertainty, and depending on the sort of modeling that you're looking at, how the uncertainty propagates through the model on the basis of the uncertainty at the input, you know, the inputs, and how that propagates through your black box or whatever model does. So it can become quite complex with complex systems, and there's different ways of coming up with a proxy measure of uncertainty from statistical methods. But the other aspect is also, as you mentioned, how to provide that to the user or to the stakeholder or end user, in the sense that it's, especially with raster data sets, you've got a map with your output. So if you're looking at, I don't know, probability of water, for example, in your across a region if you're doing flood mapping. So you've got a nice spatial 2D map, but then the uncertainty that goes with it. Do you provide this as a separate layer that you have to put next to the original map, and so on? And there's been I'm aware of, again, I need to dig it up, but there's different ways of providing a visual overview of the uncertainty that combines both the data itself plus the uncertainty associated with it, in a kind of self-contained representation. And it's tricky, right? Because you've got a two-dimensional raster, but then what do you do with a third dimension, right? So there's different ways of looking at it. I'll look it up over the next couple of minutes, and I might put a couple of links in the chat, because yeah, it's, again, people are looking into that and trying to make the most of these different dimensions.
Okay, thanks. Yeah, I'll check those out. That was probably the main questions I had. So, if there's any other questions?
Yeah, thanks, Josh. Really appreciate you. Yeah, having a think about what you want to do and coming with those questions are really valuable for us, and hopefully those answers help. Very good. Is there anybody else on the call that would particularly like to talk through what they're thinking about working on, or any challenges or questions they've run into? I know Akashi reached out to me to talk about something, so we could talk about that now if you like.
Hi, Caitlin.
Hey.
Hey. Yeah, I wanted to ask about the tree AI detection program. I understand that you're the one that have developed this thing, and so I was wondering, like, which is the source that you use as the baseline reference for trees, and how do you use the AI to detect it?
Yeah, so this was work I did here in Australia, actually using aerial imagery. So rather than satellite imagery, using aerial at sort of 10 to 20 centimeter resolution, so much higher resolution, so you can resolve individual trees. And at that point, it becomes sort of possible to use computer vision techniques like object detection or semantic segmentation to identify trees. So for those sort of AI machine learning approaches, you need a training data set, so some imagery where you've delineated what which areas of the image are trees and which are not trees, or other features if that's what you're looking for. So for semantic segmentation, it looks like, a drawing around the tree canopy. For object detection, it's more like a bounding box that you draw around the tree. So those methods may be feasible with satellite imagery, but I think that because you don't have quite the same level of resolution, those sort of computer vision techniques aren't quite as strong as, perhaps something like a random forest classifier or other machine learning approach that's used to do that sort of classification. So I think when we were talking before, you sort of mentioned about like identifying trees in urban areas and understanding flooding. I think you would need reasonably high resolution data to be able to do that, particularly with that sort of computer vision technique. So yeah, I don't know. Certainly you can do sort of things on a broader scale with the satellite imagery, and maybe even if we had a question in the tech drop-in earlier about sort of planet imagery, being available. There may be some for Southeast Asia through the Norway, I forget what it's called, but as a climate initiative. So I'll try and find the link again for that data. But I think that certainly it's definitely possible to use machine learning to kind of identify those sort of features, but I suspect that sort of supervised learning for satellite imagery might be a better fit than computer vision techniques, just because of that resolution limit.
Yeah, because like for me, I don't really have like artificial intelligence or machine learning techniques. So it's like I'm not sure if the existing software that I think there was one that you made available. Like, is there any chance we just use that directly, or do we need to still learn machine learning and then to reiterate whatever you have shared to the spatial data we have?
There are some examples, like particularly with crop type detection that we're doing in Digital Earth Africa that could be fairly straightforwardly adapted to EASI. So you need training data to be able to do that. But certainly it's something that you could have a look at this week, and maybe that's one of the problems that you kind of articulate, is that you need training data to be able to do that. So what I can do is I have to go back and look up what the source code was that we used, but I can dig out the link for Digital Earth Africa that we're doing the sort of general machine learning classification approach, and that's for sort of a crop, trying to identify areas as crop or non-crop. We're also at the moment have active development going on in sort of identifying particular kinds of crop, or other or land cover. So, is this area open grassland, or is it trees, or is it water, or these sort of things? So making land cover maps, and a couple of other bits and pieces as well. So yeah, I might go quiet for a moment and see if I can dig out some of those resources for you, and I'll try and dig out the some of the existing code that exists for doing more of that computer vision type project, because there are open source libraries that are there where they use transfer learning. So as long as you could get enough high resolution data, then it's something that you may be able to use off the shelf as a sort of first pass, and then refine it further.
Okay, thank you.
May I add something, Karen? Yeah, thanks. From the conversation, it's also related to this talk that Akash mentioned, and as you mentioned, like it's a classification, like whether there is a tree or there's no tree, there is crop, there is no crop. I just move a little bit to the water side, since in the EASI platform there is one case study about water observation from space. So in our group at the breakup room, we talked about what if we dig a little bit more about soil moisture and water observation from space. So these are two different things, but kind of related through the water dimension in it. But we had a look at the CCA's soil moisture information. It looks like very compact, and would it be possible to also link with the water observation from space at the EASI platform? Like, what would be necessary to kind of combine those? Like, what are the necessary data? Maybe there is a need of more observation. And the question we had is that marketable? And what kind of challenges we might have with data set securing or something like that. So this is a discussion we had earlier. So I just get this kind of nice chance to talk also about that. Yeah, thanks.
Yeah, thanks, ma'am. I really appreciate your question. I wonder if Eric or Matt, you have something you'd want to add about that?
Try.
Yeah.
on one hand, combining data sets is just a technical and programming task to some degree, but you have to know the context of those data sets and marry them up correctly in a scientifically justifiable manner. But in terms of getting good soil moisture data, you can get it from satellite to a reasonable degree. There have been satellite series launched in the past. The Europeans have done quite a bit with this. There's a SMOS, SMOS satellite once upon a time. Might have new generations these days. And I guess there's also potential to get a skin or surface reading from radar imagery as well, to some degree. That's about all I can say on it. It's not, most of the work we've done in CSIRO around soil moisture has been from a hydrological modelling point of view. So you're looking at the meteorological parameters and the terrain, and you're working out how much runoff are you measuring in the rivers, and how much fell, and work out the difference in between, and you've got evaporation and soil moisture somewhere in there. You would need to, as I understand it, you need to validate that approach with soil moisture measurements and soil moisture sensors. That's about all I can say on that. The only other thing I'd add in addition to soil moisture, you may want to consider soil salinity at the same time. Because depending on the environment, of course, estuarine and basin kind of environments, like the Mekong, the lower Mekong and so forth in Vietnam, an estuary environment like the lower Mekong has a lot of agriculture and a lot of aquaculture going on. So if the water table changes, or you're getting influx up the coast and the salinity balance changes, then it can affect the agricultural outputs to a large degree. So there's two lenses on a similar problem, I suppose. Again, it comes down to we can do an amount of measurement from space, but you're going to need to tie it down, I think, if you want to get to the farm level.
Yeah, thanks, Matt. One of the things that the group was discussing also, like even if there will be a focus on soil moisture, what would be which field it will be applied on? And there was a discussion on whether it will be on crop agriculture, or also from other members, application to like drought monitoring, like presence or absence of water, and is it permanent, is it temporary? I think the idea is a nice start, but as Matt mentioned, we should be careful on those kind of necessary, like to validate the data, we would need the soil moisture sensors result. Combining with the soil salinity is, I think, very important. And if we talk about island systems, there are fresh water lands and marine lands. There's always a fluctuation depending on many other groundwater or rainfall or runoff parameters. So we should be careful technically and also on the feasibility on how to do the program. Yeah, thank you.
Well, thank you, Ben. That's great. We've got another sort of half an hour available today for technical drop-in questions. Is there anybody else on the call that would like to raise a challenge they're having or talk through some of the work they're doing?
It's not a technical challenge as such, but I figured it might be valuable for the group at the moment as a whole. Just to say that we have a really great group of people from across Geoscience Australia, Frontier SI and CSIRO and Symbios here who can help you with, even if you have the most vaguest idea, we can start talking about, well, is there a potential customer? Could this be useful? And help you with some of that very early thinking before you even start thinking about, is there data, like, will this work on the platform? Is the science sound? So really encourage everyone to just feel free to reach out to any or all of us. And between us, we'd be delighted to help you along with that journey and help connect you with the right people. And maybe this is the right event to be doing something specific, or between us, we're also involved in lots of other activities and groups. So we might be able to send you off in a different direction again. So yeah. Just keep that in mind. We're here. We really enjoy this stuff. We really enjoy being helpful. So if you've got even the inkling of an idea, let us know. We'll see how we can help you.
Thanks, Anna. That's a great addition.
Same here. I'm Fabiana from Amazon Web Services, and I support both EOCSI Australia and CSRO in some of those projects, most of them actually. And I just would like to let you all know, if you need anything from us, please reach out. We are more than happy to accommodate and help you if we can. Actually, I was just talking to, no problem. I was just talking to Matt in one of the breakout rooms, and I was just saying that, you know, we're talking about some of the value that we bring is not only in the infrastructure side, which of course is the main thing, but we also have contacts these days in science and research worldwide. So we have had the opportunity to connect people from all around the world on some of the projects that we are doing. And we are more than happy to bring this to this group as well. So yeah, just a quick intro here.
Thanks, Fabiana. That's wonderful. I actually have a question for you in terms of, you know, some of what AWS is doing. I wonder whether, do you know if there's been much use of Amazon SageMaker, which is Amazon's sort of machine learning platform for Earth observation, or any of these sort of applications that we might be discussing here, just in terms of thinking about ways people can kind of get into machine learning?
Yeah. So we do have, in addition to the traditional options, right, that you go to Amazon and get a CPU-based machine, or even one of the large GPUs, we do have Amazon SageMaker. So as you mentioned, SageMaker is our platform for machine learning. And one of the things that you can do is to run Jupyter notebooks straight from the SageMaker console. So why is that interesting? I think the value there is you don't really need to worry about infrastructure. So you can imagine someone just gave you a Jupyter notebook there, and you can work with it, right? A couple of things that we are doing is we are talks with, you know, how we can leverage that in EASI at the same time. So we're doing some research on that, because some things will be way better running on EASI, but perhaps if you go to SageMaker, you can take advantage there, or have, you know, lower your cost. One of the things of my job, and that's a funny one, but that's what they pay me for, is to reduce my customers' bill. So how you can get more research outcomes with less investment. So that's where SageMaker could be a potential opportunity, right? So yeah, very happy to discuss and bring the solution at some point if you guys are interested, right?
Yeah, thanks, Fabiana. That's really interesting. So having heard a little bit about that, does anyone have any sort of questions about how they might sort of, you know, even any general questions you have about cloud computing. I think, you know, while we have Fabiana here, it's like nice to ask those sort of questions, and Matt as well, about how, you know, what can be done in this space, or even any general questions that you have about what you want to do moving forward. And like Emma said, we can talk about, you know, the market for your idea. I know that some of the Asia Link sessions have been all about that. So yeah, this time is very much for you. If you are also, you know, feeling overwhelmed, you don't, you can use this time to take a break. If you need a break, it's all good.
Hi, I have a question. I think maybe I can ask it to Eric and Matt that wasn't earlier during our earlier discussion about flood. So I was asking earlier during the morning tech session, what are the data sets that we need if we are going to measure flood of a region, and what do we need to do to this data? So I think Keely mentioned something like we need DEMs and slope angles. So I was wondering, is there any other forms of data sets that we would need for us to do a very holistic and accurate flood prediction?
I'm not quite sure how deeply you want to go in flood prediction, and I have no experience with that. But I suspect if you want to launch into modeling of flooding events, you probably want to have access to precipitation data, and potentially numerical weather prediction as well, in terms of, you know, trying to work out what's going to happen over the particular catchment of interest. So yeah, that's the things that come to mind, but I'm definitely not an expert. I've done a bit of water mapping, so flood detection from remote sensing data. But if you want to look at prediction, then I suspect you will want to start doing some modeling, or I suspect that probably deep learning might come in handy here as well, some kind of machine learning approach. And I suspect there's a wealth of research that has been done in this field already, and you might be able to find literature and papers online that discuss potential approaches and, you know, related data sets that are needed for these different methods.
Yeah, I think on that point, one of the data sets we've worked with in Digital Earth Africa is CHIRPS, which is a rainfall sort of precipitation data set. I don't know if it's actually like worldwide or what the coverage is. Okay, so I'm having a look here. I'll post a link in the general chat. This is their data repository. And so I'm not really sure what the resolution would be, but you could sort of have a look at their README and dive into it. But you can, on that link, you can see they've got sort of folders specifically for Africa and then some for global. It looks like there's an Indonesia monthly in there as well. And if you kind of dive down into that, there's tar files, and from there you may be able to extract some sample rainfall data that you could have a look at. So Matt's put the what's that one, Matt?
GPM, Global Participation Measurement Mission. So it's
great.
Between, as I understand it, between CHIRPS and GPM, they're the two global satellite-derived gridded precipitation products. CHIRPS is a little bit more tied down to WMO monitoring stations, and GPM is a little bit more consistent through space or time, through a merging and melding of the different satellite sensors over time that have been trying to measure precipitation. We do have GPM in. We can do chirps because Africa have already done it, as Caitlin said. They're both valid to have a look at. I did a little bit of poking around once to see GPM versus chirps, and it really seemed to be horses for courses. In cases where people were validating within 5 or 10 kilometres of a WMO station, then chirps was better because it's tied to them. But outside of those areas, it was, yeah, pick which one works best. So they're both valid. They're both good to go.
Yeah.
National resources, national weather data sets for precipitation and meteorology would be interesting to look at as well.
Okay, thank you.
Yeah. And I think really that, you know, the people in this forum, we all have a sort of broad range of expertise, but none of us are sort of very specific in any of these areas. So certainly if you are sort of out there looking for what people are doing in the literature and you come across something, but you're not sure whether it's relevant or whether it is something that you could implement, you know, we do have sort of some good combined expertise to help you kind of assess that, but certainly we don't know absolutely everything everyone is doing out there. So I definitely would suggest a bit more, you know, of that wider literature search, if that's, you know, the path that you're interested in going down. And we can help with sort of evaluating whether those ideas will translate into this sort of space. But certainly, you know, flood risk modeling isn't a problem that, you know, is definitely solved or 100% solved, and certainly not 100% solved by us. So yeah, we would like to work with you to identify, you know, what are some promising paths to go down. So I think in addition, Akash, these data sets of looking at precipitation may help, but also I think looking at what's been done by others in terms of if you're sort of looking up Earth observation data in flood prediction or flood risk assessment, I think would certainly be interesting. Other things you could consider is sort of, you know, adding in data from something like OpenStreetMap, in case that, you know, is a free open source mapping of buildings and infrastructure that you could then, you know, understand. Other things you can do is look at population density in terms of understanding, you know, where people are placed. And certainly, I think Facebook has an open data set. And again, there's all sorts of questions about how accurate these data sets are, but they may at least be a starting point. So I think that if, you know, given your interest in this, and I think that's a really valid and relevant interest, it may just be a matter of doing a bit wider of a search beyond just what the expertise we have here. And I'm sure you're already doing some of that looking. And so we're, yeah, try and help you as best we can. But I'm super interested to see what you turn up.
No worries, thank you. So
so probably got another 5 to 10 minutes left, and then we might wrap it up so that everyone can have a bit of a break before the final session for today, which will be another AsiaLink session. So are there any other questions on the call or anything people would like to talk about? Oh, good. So yeah, I'll be staying here on the call for a little bit longer. Oh, Bam, did you have a want to raise your hand?
No, sorry, I just made a mistake of choice. But
all
thanks a
good.
lot. Thanks a lot. And all our queries and the things we wanted to ask were addressed. Thanks a lot.
Oh, you're very welcome. Yeah, so Fabiana's put her email in the chat if you'd like to get in touch with her. I'm on the Discord and having a look in the sort of tech channel, but you can also message me directly if you want some support. Yeah, we're here to help you as best we can. So yeah, please let us know if there's anything we can try and assist with. But otherwise, yeah, I'm gonna stay here on the call. So if anybody wants to speak up and ask a question, go for your life. But for everybody, I definitely encourage you to take a little break now for 15 minutes before the final session of today, so that you're feeling, energized and engaged. Get up, stretch your legs. And yeah, we'll be sort of seeing you back here in about 15 minutes. But yeah, I'll still be here if you want to ask anything.